Good afternoon, President Binder and members of the Commission. For the record, I am Liam Mooney, Cameco's Vice President of Safety, Health, Environment, Quality and Regulatory Relations. With me today is Dr. Brett Moldovan, the Acting General Manager of Cameco's Key Lake operation. I should note that Dr. Moldovan, while new to the role of General Manager at Key Lake, was mill manager for the previous 3.5 years and has worked for more than 20 years at Cameco. Also with us today is Kevin Himbo, Manager of SHEC Regulatory Affairs and Risk Management at Key Lake, and Kevin Nagy, Director of SHEC Compliance and Licensing for Cameco. We are here today to discuss an event that occurred at the Key Lake Mill involving the release of a small amount of calcined uranium into an area of the Yellowcake building. At the outset, I will speak briefly about our health and safety programs as well as our performance in this regard, and then turn it over to Dr. Moldovan to discuss the event in more detail. In addition to providing you with further details of the event, we will also outline steps that we have taken to ensure worker health and safety is protected and to prevent a recurrence in the future. At Cameco, the health and safety of our workers and the public, as well as protection of the environment, are our highest priorities. Consistent with this, safety and protection of the environment is integral to everything we do at the Key Lake operation. The result of this focus is reflected by our performance. For example, in 2014, Key Lake reached the significant milestone of 3 million hours worked without a lost time injury. Key Lake also has a mature radiation protection program that is designed to keep radiation doses as low as reasonably achievable, or ALARA, relying on a defense-in-depth approach. Consequently, we have enjoyed strong performance in this regard as well. Prior to the January event, for example, the Key Lake operation achieved 630 consecutive days without exceeding a radiation action level. In accordance with our training program, Cameco trains nuclear energy workers to identify potential issues and take appropriate action. As we believe this event clearly demonstrates, training has proven effective because the concern was recognized immediately and reported. This demonstration of a reporting culture is also an important indicator of the strong safety culture at Key Lake. The combination of our strong safety culture and our various programs are also components of the broader defense-in-depth approach to safety employed at all Cameco operations. With that, I will now turn the presentation over to Dr. Moldovan.
Thank you, Liam. Good afternoon, everyone. For the record, Brett Moldovan. First, I would like to describe the operation of the calciner and its exhaust and scrubber system at Key Lake. The calciner is essentially a vertical furnace through which precipitated yellowcake is further processed to produce a dried uranium powder that is the final product of Key Lake. This is referred to as calcine, or more commonly as yellowcake. The calciner has a multi-stage scrubbing system. The purpose of the scrubber system is to cool the off gases from the calciner and remove or scrub any of the fine particulate contained in the exhaust gases. This exhaust system is designed to capture fine uranium dust particulate that is then recycled back to the yellowcake precipitation process. If I can draw your attention to the figure, the ducting connecting the calciner to various scrubber components is constructed of stainless steel with a thickness of about 1/8 of an inch. The main section of ducting that I would like to focus on is between the calciner and the quench tower. To provide a sense of scale, this ducting has a diameter of 18 inches and is 40 feet in length. Bear in mind, for some of the later discussion, you can see the extent of the other ducting in this picture that connects other elements of the scrubber system. In the upcoming slides, we will discuss in greater detail the location where the small amount of calcine was released in this section of the ducting, shown on the diagram by the letter X. With that context, let me provide you a brief summary of this event. During the course of installing new piping, workers on the 4th level of the Yellowcake building observed what they believed to be calcine material on the floor and on the equipment in their area. These workers left the area and then notified the Yellowcake operators, who restricted access. The subsequent cleanup collected about 2 cups of this material. Cameco's initial investigation confirmed that this release was localized and contained entirely to the 4th level of the Yellowcake building. Further, there was no release to the environment. Please note that the picture on the left is different in this version of the presentation. This picture shows the weld seal separation where the calcine material was released. The insulation and the cladding are removed in this image. The mill operators, as detailed in the previous slide, conducted the cleanup after donning personal protective equipment, including passive respirators. Following the cleanup, Cameco further restricted the area by designating it as a radiation work permit area. As well, the entire Yellowcake building was designated as a respirator zone. Further investigation identified the source as a separation at a weld seal between 2 sections of the calciner exhaust ducting on the 4th level of the Yellowcake building. Cameco then voluntarily initiated a safe shutdown of the entire mill at approximately noon on February the 17th. We notified CNSC staff of the event, as well as the decision to shut down the operations to conduct further investigation. Before we proceed any further with a description of the actions we have taken, I believe it is important to talk about the enhanced monitoring of the 3 workers who first observed and responded to the calcine material. In accordance with Cameco's corporate standard, we placed these 3 workers on an enhanced bioassay monitoring program. The results showed that 1 worker, the individual who was closest to the calcine material, received a dose above the weekly action level of 1 millisievert. The dose calculation for this specific event was 1.06 millisieverts. This resulted in a dose of 1.16 millisieverts for the full week of work. This remains well below Cameco's internal guideline of 20 millisieverts per annum and the annual regulatory limit of 50 millisieverts. Further, the enhanced monitoring showed the other 2 workers in the area did not receive a discernible dose. Cameco discussed results with the employees in question and then notified the CNSC. The next business day, we also posted information related to this event on our website. During the period in which inspection and repairs were underway, Cameco kept Key Lake employees up to date on this event using regular toolbox meetings. Cameco continued to maintain area controls, including restrictions on access and requiring respiratory protection throughout the Yellowcake building to manage the potential radiological risk. With regard to immediate corrective actions, Cameco removed insulation and cladding on all of the ducting associated with the calcine scrubber and exhaust system in order to conduct detailed inspections and complete repairs. Insulation and cladding was removed on all sections of ductwork shown in the previous diagram, including ducting that connects other elements of the scrubber system all the way to the exhaust stack. Thickness testing of the affected ducting showed there was no change in thickness as compared to original design and installation. The assessment conducted by our maintenance engineering department suggests the ducting was likely damaged by load or impact during recent construction activities related to the new calciner system. We believe the initial damage to the ducting at the particular point where the release of calcine occurred caused stress along the length of the ducting and resulted in 11 other weld separations. Inspections also found weld seals throughout the rest of the scrubber system ducting were in good condition. The identified weld seals were repaired and tested using dye penetrant, as shown in this photo, before the insulation and cladding were restored. In total, Cameco had the mill shut down for 12 days to conduct the inspections and complete the necessary repairs. As the work proceeded, Cameco also installed inspection and cleanout ports along strategic sections of the ducting. Further, we installed 2 additional duct hangers to provide enhanced structural support. Through the restart period, Cameco put in place enhanced radiation monitoring for this area. Swipe samples were also taken by the radiation department to confirm the effectiveness of the cleanup. Additional visual inspections and radiation monitoring will remain in place until the new calciner is fully operational. In addition to being provided with Cameco's safe restart plan for the mill, CNSC staff were also able to observe progress of the repair work during their inspection visit. Cameco has continued to make significant investments in the Key Lake Mill to ensure continued safe, clean, and reliable operations. One of the most significant investments underway is the replacement of the existing calciner with a new calcining system. We expect the existing calciner will continue to operate through the balance of 2015 while the new calciner is being commissioned. We are confident that the inspections and the subsequent repairs to the calciner exhaust and scrubber system will allow for the continued safe operation of this equipment. Cameco will also continue to conduct scheduled preventative and predictive maintenance activities on the existing calciner. As a learning organization, we have implemented a design change to the new calciner, and more specifically, Cameco decided to install inspection and cleanout ports along its exhaust system. This will increase confidence that the integrity of welds can be inspected on a routine basis. With that, I will turn the presentation back to Liam Mooney.
Thank you, Dr. Moldovan. When Cameco initiated the root cause investigation into this event, we decided that the earlier January event involving the calciner at Key Lake would also be included in that scope. This root cause investigation is well underway, and we expect to have the final report by mid to late April. Cameco's corrective action process will ensure that lessons learned will be shared at all of our operations. With the results of the investigation in hand, Cameco will be in a position to submit our formal response to the request for information sent by CNSC staff on March 11th, pursuant to subsection 12.2 of the General Nuclear Safety and Control Regulations. To summarize, these calciner-related events are of concern for Cameco. We feel that our response to them has been systematic and timely. Further, our programs, systems, and training provide defense in depth to prevent these events from occurring and limiting the potential consequences if they do happen. We believe the steps that we have taken will allow us to continue to safely operate our uranium milling facilities while protecting both people and the environment. In conclusion, we want to assure the Commission that Cameco's commitment to safe, clean, and reliable production means we are fully committed to addressing these recent events. We would be pleased to answer any questions that you may have.
Thank you.